This first problem, we have an order for heparin, 3,000 units subcutaneously, 4 times a day. The information for our drug is on the label below. So the question is, how many mils of heparin would the nurse draw up in the syringe? And you can pause it right here if you would like to try to work this out before I show you how to work it out. With ratio proportion, I'm going to put what I have dose-wise over my volume that I have, and then I'm going to put that equal to my desired over x. For this problem, my have is 5,000 units over 0.5 mils. My desired is 3,000 units. And so I want to figure out how many mils would it take to get 3,000 units. So we cross multiply 0.5 mils times 3,000 units and 5,000 units times x. We end up with 5,000 units x equals 1,500 units per mil. We divide both sides by 5,000. So over here it will cancel out, and then on the right side we will punch that into our calculator. And I like to cancel out my zeros before I punch anything into a calculator. X equals 0.3 mils. In our second problem, our nurse has an order to infuse 1,000 mils of normal saline with 10 mil equivalents of potassium chloride in 480 minutes. At what rate should that nurse set the IV pump? We're looking for mils per hour. This would be a good place to pause if you would like to try to solve this problem on your own before I work it out. For this problem, we know that we have 1,000 mils that's going to infuse over 480 minutes. So then that would be equal to X, because we don't know how many mils are going to infuse over 1 hour, which is 60 minutes. We cross multiply and we are going to end up with 480x equals 60,000 mils per minute. We divide both sides by 480. 480 just cancels out on the left side. On the right side, we get 60,000 mils divided by 480 minutes, and that's going to give us 125 mils per hour. In this problem, we have a client who is MPO with an order for 1,500 mils of D5W 0.45% normal saline with 30 mil equivalents of potassium to be infused over 14 hours. How many mils per hour should the IV pump be programmed for? This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. So we have 1,500 mils that's going to go in over 14 hours, and that's going to be equal to how many mils in 1 hour? We cross multiply and we end up with 14 hours x equals 1,500 mils per hour. We divide both sides by 14 hours and we end up with 107.142857. For this problem, we are going to round to the whole number. What I will advise you to do is follow the directions given to you for each individual problem. It will tell you exactly where to round to. We are rounding to 107 because it is the nearest whole number. with the tenths place. If it is between 0 and 4, we're going to round down. If it's 5 or greater, we will round up. Rounding to the whole number, we are going to end up with 107 mils per hour. Problem number 4, the client is scheduled to receive cephalexin 4 grams in 150 mils of D5W. According to the pharmacy, this preparation should be infused over 90 minutes. Calculate the correct flow rate for this medication. We are looking for mils per hour. This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. So we know that we have 150 mils that goes over 90 minutes. But what we're looking for is how many mils are going to go over 60 minutes. We cross multiply and we end up with 90 minutes x equals 90,000 mils per minute. We divide both sides by 90 minutes and we end up with 100 mils per hour. For problem number 5, we have a nurse that is preparing to infuse 1,000 mils of 0.9% sodium chloride IV over 10 hours with a tubing set that delivers 20 drops per mil. The nurse should infuse the IV fluid at how many drops per minute? I want to stress that this method is not the best method to use for IV drip rates and actually takes 3 steps to solve. I encourage you to watch the IV calculations video in your math module in Canvas. This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. X. So what do we know? We know that there are 20 drops per mil, and we know that we have 1,000 mils, but we don't know how many drops total that's going to be. So we have 20 drops over 1 mil equals X over 1,000 mils. We cross multiply and we end up with 1 mil X equals 20,000 drops per mil. We divide both sides by 1 mil, and what we know now is that we are going to have a total of 20,000 drops. The next thing we know is that there are 60 minutes in 1 hour. So 60 minutes over 1 hour would be equal to how many minutes over 10 hours? We cross multiply and we end up with 1 hour X equals 600 minutes per hour. We divide both sides by 1 hour and we are left with 600 minutes. So now we are in our final step. We are looking for drips per minute. So we know we have 20,000 drops over a total of 600 minutes. We know that that is equal to how many drops over 1 minute. So we cross multiply and we end up with 600 minutes X equals 20,000 drops per minute. We are going to divide both sides by 600 and we end up with 33.333 repeating. We cannot have a fraction of a drop, so we are going to round to the nearest whole number, which is going to be 33 drops per minute. For our final problem, we have a physician order for digoxin 0.25 milligrams IV every morning. The available vial reads 0.5 milligrams in 1 mil. The nurse would administer how many mils? This would be a good place to pause if you would like to try and solve this problem on your own before I work it out. So we know that there's 0.5 milligrams per every mil, which would be equal to 0.25 milligrams per X mils. We cross multiply and we end up with 0.5 milligrams X equals 0.25 milligrams per milliliter. We divide both sides by 0.5 milligrams and we end up with 0.5 milliliters. Thank you for completing this video. Please be sure to take the post-module quiz.